Today we are comparing ionic, covalent, and metallic bonding. In ionic compounds, an electron is transferred to another atom. In other words, one atom loses an electron and one atom gains an electron. In covalent bonding, electrons are shared between two or more atoms in an electron cloud. In metallic bonds, electrons are not transferred or shared between atoms. Rather, there is a sea of electrons that is composed of the mobile valence electrons found in the outermost energy level. The picture of the electrolysis of copper 2 chloride displays the role the electrons play in forming an ionic bond. The copper ions are attracted to the anode, which is evidence that the copper ions are positive. The chlorine ions are attracted to the cathode, which is evidence that the chlorine ions are negative. There was a transfer of electrons to create these cations and anions. Next, let's compare the structure of these three types of bonds. First, I'll be addressing the ionic compound. In ionic compounds, a regular repeating pattern of negative and positive ions form a crystal lattice. Covalent compounds are formed by the sharing of 1, 2, or 3 pairs of electrons, resulting in single, double, or triple bonds. Bond length also determines how strong the bond is between molecules. The shorter the length of the bond, the stronger the bond is between the atoms. According to structure, metallic bonds are similar to ionic bonds. They form lattices in the solid state, which are like the crystal lattice structure formed by ionic compounds. As far as conductivity goes, ionic compounds are not conductive in their solid state. However, when dissolved in solution, they are highly conductive. Covalent compounds are poor conductors of electricity, regardless of their state of matter. Metallic compounds are good conductors of electricity because their atoms are surrounded by a sea of electrons. Next, I'll be discussing the general properties of each type of compound. Bond strength plays a vital role in determining the properties of compounds. Ionic compounds have high melting points and high boiling points because of their ionic crystals, which require a large amount of energy to be broken apart. Ionic compounds are also hard, rigid, and brittle. Covalent compounds have lower melting and boiling points due to the weaker attraction between molecules, meaning a smaller amount of energy can melt or boil the compound. Covalent compounds are also soft due to the weaker bonds between molecules. Metallic bonds have moderately high melting and boiling points. They are ductile, which means that they can be drawn into wires. They are malleable, meaning they can be hammered into sheets, and they are relatively hard, but hardness depends on the number of delocalized electrons. Moving on to the smallest unit of each compound. Formula units are the ionic compound's smallest unit. Molecules are the smallest unit of covalent compounds, and finally, atoms are the smallest units found in metallic bonding. Lewis dot structures are used to represent each type of different bond. Here is an example of an ionic compound's Lewis dot structure. As you can see, sodium has 1 valence electron and chlorine has 7. Sodium transfers its 1 valence electron to chlorine following the octet rule. This results in a sodium cation and a chlorine anion, where they are attracted to one another, creating a stable compound. The next example is the Lewis dot structure of a covalent compound. In this case, there are 2 fluorine atoms, each having 7 valence electrons. They share 1 electron, resulting in a single covalent bond. Metallic compounds are not represented with Lewis dot structures since they are not transferring or sharing any valence electrons. Lastly is naming ionic and covalent compounds. This flowchart is a good representation of the process used to name ionic compounds. First, you name the cation. If it is a transition metal, tin or lead, a Roman numeral is used to indicate the charge of the cation. If it does not fall in this category, no Roman numeral is necessary. Then name the anion, changing the ending to "-ide". To name covalent compounds, prefixes are used to indicate the number of atoms in the formula of each element. The second element's ending is changed to "-ide". Well, that was the conclusion to this lesson on comparing ionic, covalent, and metallic bonding. I hope you liked it. All information was found in this textbook.